Alrighty. Hopefully this works well. I'm not sure how I'm going to upload it, but we're filming, so that's a good start. Um, I hope everyone's having a nice weekend. We're starting at 7E, so that's page 14 and your band reference. You should have it on you, making sure you're pausing and opening to page 14 if you do not have it ready to go. We're starting to now give our graphs numbers. So we're giving them weight, they're called weighted graphs, and we're finding the shortest path. So we're just starting with like it's maps, and then trying to figure out the quickest way to move between an area, so the shortest way of traveling between it. Um, so this first, just taking note too, it does say here in time, distance or cost. So it could be a money problem, we're treating out the cheapest way, could be a time, so the fastest, or distance. So moving between this, it's important we read the question to get the full context. So the following weighted graph shows the distance in kilometres. That would be an important piece of information you'd want to highlight, distance in kilometres. Between 6 suburbs A, B, C, D, E, and F. Importantly, know this because you'll lose marks if it is not in the correct unit when you're doing these questions. Calculate the total length in the following routes. So, as we've gone through already, A to B, B to C, C to D, D to E, and E to F. This represents all of our vertexes and the journey we're going to travel. So, starting at A, we're going to get A to B, which is 6. Then we're going to go from B to C, which is 8. Then we're going to go from C to D, which is 2, D to E, which is 2, and then E to F, which is 6, back down this way. And we're just adding that total to see what that trip would take us. Now, you could highlight that out if you wanted. You could draw, underline it, shade it if you really like. If we're doing multiple questions, it's probably best to leave your graphs as untouched as possible, just in case we need to pull out that information again. So moving on to this next one, we're starting at F, then we're going to go to D, to C, to B, to A, and then back to F, right? So noting that this one would be a circuit if we were looking at it. So starting at F, moving to D, we've got 7, then to C, we've got a 2, so that's there. Then from C to B, we've got 8. Then from B to A, we've got 6. And then from A to F, we've got another 5. Right? Adding all those numbers up. Group friends of 10, do whatever you need to do. But like if I was looking at this one, I see a group of 10 there, then 7, then 23 and 28. So we can just do those problems nice and quick in our heads. If you're not confident, use your calculator. Double check them always. Good to be certain. Moving on, so the shortest path by inspection. Now, just by inspection, now we are going to learn methods of moving between these graphs and using like specific processes. For now, we're just looking at how we're going to move from here to here, what's the best way to do it, and basically trial and error is your friend, right? If you have a calculator, you might use that to quickly enter these if you're not confident in doing like these short kind of addition problems in your head. But I would start with a path that it looks like kind of the shortest. So maybe you start with one that's like F, A, B, C, right? So we might write that as F, A, B, C, right? And we can then apply the values to it. So that would be 6 plus 7 plus 5. A, 6, 7, and 5, right? I'll go the 3 then. And work that out to be, so we've got 6 and 7, so 13 plus 5 is 18, that would be 18. Noticing it doesn't actually tell us in this question what that's worth, so we're happy to leave that at 18. All right, then we might try another one that we think could get us there. Like, obviously, if I'm moving from E to D, that's 9 already, so we could maybe look at getting there 4 to 5. We could go to D via B, and it would be the same distance. So this route we can kind of like rule that off as not as important. So we're not really looking at that. Then we could go the 6 to figure that out. So let's try that one. So let's try F to E, and then I want to avoid that 9. So then to B, and then to C. So F to E to B to C. Radio, F to E is 7 plus 4 plus 5, right? 7, 4 is 11, plus the 5 is going to be 16. Right, we've already ruled out that pathway, so we can then go, right, well, so far that's our quickest way. Can we do any better? So let's check. Well, 7 plus 9, right? That's going to be 16 already. So this is not worth it. It's no longer going that route. It's going to be better than 16. So maybe to 7, to 4, to 5, then plus 6 is not going to work. Can we do it this way? So we already tried FABC. I don't see a better way on going about it based off just that elimination of once I've got a number like 16, I can rule out other methods of getting there just by kind of yeah, avoiding those pathways. So this would be our quickest route. Good. Moving on. So this next question here says, I'll just kind of adjust, sorry. Um, identify the shortest path in the network by inspection. The network shows distances in kilometres along the roads that connect cities from Austin to Boyle. Find the shortest distance in kilometres from Austin to Boyle. Now, this one there's going to be lots of options, right? So we might want to find maybe just by looking at small numbers, that's always a good place to start. We have to get here, and I know I can get to here for less than even being here, right? So I've used 2 to be along this path, and I'm using up 5 to get back here, or I'm using 7 to get back here. So probably getting to those 2 is a good place to start. Now, quickest way to get from Austin to here, right? We could go the 2 to the 4, could do that. That would be 6. We go the 5 to the 3, that's going to be 8. So we could do that. It's going to be better to do this way. And that 1's better than 3. I'm seeing a direct route kind of popping out to me already. So I'm going to try that. So let's go through and label the rest of these. If I did that as A, B, okay, so we've got a bit of a pattern. C, D, E, F, G, H, and I, right? And we've got a bit of a pathway. We would go A to H, yep, H to G, yep, G to F, F to B. And that would be 2, 4, 1, and 1. Right, that's a pretty short distance. So 2 plus 4 is 6, 7, 8. That is the distance of 8. Let's see if we can kind of eliminate some pathways just by doing that. So here is 1, 2, 3, 4. 4 plus 5 is going to be 9, so it couldn't be that way. Is there a shorter way of getting there? That's a 5, so those I could get to there again, but it would be 5. That's the 1, 2, 3, 4, 5. That's 10, so it's not quite shorter to go that way. Basically, I feel like you're able to rule out pathways just from where you've started, where you finished in our number. I'm not seeing anything shorter than that. Correct me if I'm wrong. What's this one? 3. That's 7, 8, 9. Yeah, so then plus 5 is going to be over. We're breaking all of those straight away. So this is our shortest pathway now. Now that you didn't just we've labeled it, but always good in a question where it's over. This is the last question on the page to go through and highlight that journey. We'll draw on it. So that one, we went to there, to there, to there, to there. Right. Process of elimination, starting with the one you think, and then kind of reverse engineering that number to see if we can beat that in any way possible. Really good start. Hope that helps. Thank you. Bye bye.